All right, we're going to go over the answers to the quiz you guys took on Friday. Let's take a look at part A. At equilibrium, are reactants favored? Well, the K value is really large, indicating that there are more products than reactants overall. We say that if K is greater than 1, then the reactant is product favored. Okay. Part B, what is the value of the equilibrium constant for this reaction? Well, you'll notice that this reaction is actually the reverse of the top reaction, so you have to take 1 over K, and it's also divided by 2, okay, or multiplied by 1/2. So you also have to square root the K value. So the final answer would be the inverse and the square root of the initial K. Okay. For part C, the equilibrium expression is just products over reactants with everything raised to their exponents, or their coefficients rather. So for Kc, it's the concentrations of products and reactants. For Kp, it's the partial pressure of the products over the partial pressures of the reactants. For part D, Kp equals, here's the formula, RT to the delta N. Delta N is the change in the number of gaseous molecules. So for this reaction, there are 2 on the right and 1, 2 on the left. 2 minus 2 is 0. So Kp equals Kc in this particular case. How would the addition of more hydrogen gas shift the reaction? Well, if you add hydrogen, it's going to try to use the hydrogen up, so it's going to shift to the right. Okay. And for part F, when the reaction vessel is cooled to lower temperature, the value of K becomes larger. Okay, that's bigger than the initial. Well, as the temperature goes down, there are more products formed. So you're basically taking energy away and shifting the reaction to the right, making more product. Okay, so we're taking energy away, shifting it to the right. That means the energy must be on this side, the products. If you're taking it away, and the reaction is shifting to make more. Okay, therefore, it's an exothermic reaction. And for part G, since the value of K is larger than 1, the reaction must reach equilibrium quickly. No, no, no. Equilibrium says nothing about the rate of a reaction. So that one's false.